question number 2, right? So we'll consider with the same supply and the resistive load for full wave controlled rectifier, right? So here controlled means there's a gate signal, right? So show that the average output voltage of the rectifier is given by this, right? So we average Vm over 251 plus cos alpha, right? So in here, so this is the supply, right? And here this is what you will get as. So here 5 plus alpha, and here this is 2 pi, so 0, right? So this is the output, the red color one, that will be the output. So therefore you have to find the average. That is, in order to find the average, we will consider this, right? Phi of the angle, then find the area of this, then divide by 5, right? So therefore 1 over 5 from, we are just integrating from alpha to 5 VST, right? So here this is V max or Vm sine omega t or Vm sine theta, the same thing, right? So if you are using like omega t, we have to integrate with respect to d omega t. So 1 over 5 from alpha to 5 V max sine omega t d omega t, right? So if you substitute this sine omega t, you will get for the integration minus cos omega t, and substitute phi and alpha, so you will get 1 plus cos alpha. And if you take a look at so here this should be should not be 2, right? There should not be 2, right? So if you compare with the previous average, right, here can you see in here we have Vm over 251 plus cos alpha, and here what we have is Vm over 51 plus cos alpha. You will get, right? V average, right? So what you can say is the V average of the full wave, it is twice of V average of the half wave, right? Then find the RMS voltage across the load, right? So how to find the RMS voltage? Vrms, it is equal to, within square root 1 over 25. So from 0 to 25 you have to integrate Vt squared d omega t, right? So then if you substitute for Vt, which is V max sine omega t, that is squared d omega t, right? So then what we can do is actually so you have to find the square of consider from 0 to 5, then square these values, right? Square, so because the rest is 0, so square, find the square waveform of square this waveform, right? Then you will get a different waveform. Then you have to integrate from alpha to 5 and 5 plus alpha to 2 5, right? So we have to add these two, both of them we have to add, right? So without doing that, we can just find only one, right? That means from alpha to 5 only if we find, then if we multiply by 2 we'll get both areas. So this one and this area, right? We get both areas. Okay, so therefore we get both areas. So find one, let's say we find this one, then multiply by 2, right? Actually not this area, after squaring it, right? After squaring it you will get some waveform, and you will get the same shape for both portions, right? So therefore find one, then multiply by 2, right? So find the RMS voltage across the load. So that is what we are going to do here. We will integrate from alpha to 5 sine omega t squared, so that part, so V max over 2 5 and everything we have taken out, so multiply by 2, right? We'll do only one portion, then multiply by 2, right? So if you integrate from this So 2 will cancel out, right, from here, since we multiply it by 2, right. Then again, what you will get is, so v max we can take out, right. uh, Alpha to phi 1 plus cos 2 omega t divided by 2 d omega t, right. So like that you can substitute, right. So you will get here for this one, for this one you will get the same value that we have found previously, right. So here you have the same integration here, you have the same integration of this, right. Same integration of this, so only the thing is, yes, we have multiplied by 2, right. So here you will see, you'll get root 2. So if you compare it with VRMS of the full wave and VRMS of the half wave, right, this is equal to root 2 times VRMS half wave. It is not doubled, right. Only the average is doubled, right, because it is obvious, right, because here we are getting 2 of them, both half cycles we are getting, and here you will get only root 2 times VRMS of the half wave, right. Then here you are asked to determine when alpha is equal to 30, right. So the RMS you can calculate V max, so the maximum voltage, it is equal to root 2 into 240, because RMS is 240, right. So divide by root 2 and 1 minus here 30 over 180, as I have said previously. If you are substituting alpha in degrees, phi should be also in degrees, right, or else both in radians. So sine 2 alpha 2 phi, so you will get 235.9 volts, right. And again here VRMS, and here IRMS, and here it is R, right. So IRMS equal to VRMS divided by R, so VRMS is 235.9 divided by 100, so 2.359 amperes you will get, right. And how to find the power of the load? Again, the power of the load is IRMS squared into R, so you'll get this value. Then overall power factor, how to find power factor? So this power you have, and the S you can find from RMS voltage into the current, and you will get this much of the power